This video will cover the practice test for maths applied geometry. You can use the time tags in the description below to skip to the question type or numbers that you need help with. In this video, we'll assume that you guys are familiar with a lot of the rules based around complementary and supplementary angles in geometry. We'll also assume that you know that things like vertically opposite angles at a point are equal, and you need to be familiar with the rules around angles with parallel lines as well. There's a few different ways of solving some of these questions, but the new information is these two formulas here. So if you're given a polygon, which is a two-dimensional shape, we can calculate the internal angles using these two formulas. Importantly, if it's a regular polygon, that's a polygon that's got equal sides and angles, you can use the first formula, which is to calculate an individual angle. And so if you use this formula here, you'll be able to work out what an individual angle is. You might notice particularly this little section of the formula is different to the one below, because the top section calculates the total sum of all the angles in the polygon, and then by dividing it by the number of angles, you end up with the individual angle. It's important that you only use this formula on regular polygons. It won't work on irregular polygons. Down the bottom, we've got a formula which is calculating for the total sum of all the internal angles. And you can use this on any sort of two-dimensional shape or polygon that you like. And that one is just, again, using the number of angles or the number of sides, sub it straight in, and that will give you the total internal sum. As I work through these questions, I am going to give you a verbal sort of justification as to how I got the answer. Really, you should write it down, but I won't do that just to keep this video moving a bit quicker. Question 1A is a triangle, but this triangle has an external angle, which is this one right here. And there's a rule that the external angle of a triangle is equal to the sum of the two opposite internal angles. So in this case, x is equal to 51 plus 48. So x is 99 degrees. Don't forget your units. And you'd normally justify this with the external the external angle of a triangle is equal to the sum of the two opposite internal angles. It's quite a lot to write. The second example, I've got a polygon which is a quadrilateral, so a four-sided shape. We know that the internal sum of the angles is going to be 360 degrees, so you can attack this question with that. I also see that this one's a parallelogram, so I'm going to use the rule for co-interior angles. And co-interior angles between parallel lines, so this one plus this one, will add to give 180 degrees. So in this case, I'll use D plus 75 will give me 180. And then all I need to do is just use the balance method. So I'll subtract 75 from both sides, and I'll be left with D is 105 degrees. In question 1C, I've got a triangle, so this one's a three-sided polygon. So we know that the internal sum of all the angles is going to be 180 degrees. But there's a lot of algebra in this one. So what we'll need to do is we'll need to just separate those two things. And if I think about it, I know that this angle plus this angle plus this angle is going to give me 180 degrees. And so I'm literally going to write that. I can see that I've got two 3x plus 10s here. So I'm going to say, right, I've got two angles that are 3x plus 10. And I've got another angle which is 4x plus 10. Whoops. Making a mess of this. And that is going to add to give me 180 degrees. Now I'm going to switch off the geometry and just ignore it. So I even can hide that. And now what this is just straight algebra. I'm just going to expand, collect my like terms, and simplify for x. So 2 times 3x makes 6x's, 2 times 10 makes 20. I've still got my 4x and my 10. Now I'll collect up some like terms. I've got 6x's and 4x's, that makes 10x's. I've got 20 plus 10, that makes 30. Now I'm down to the balance method. I'll subtract 30 from both sides. I'm left with 10x's on the left, and I'm left with 150 on the right. Tells me to times by 10, so I'll divide both sides by 10. And now I've got the x is 15 degrees. Not forgetting your units, but that question is solved. All right, question 1D. These are called vertically opposite angles. So this angle is equal to this angle. This is just a little different because it's got algebra in it, just like the one above. Try not to think about it too much. If I know that those two are equal, that means that 2x, minus 30 is equal to x plus 28. So in other words, vertically opposite angles are equal. Each of those is equal to one another. And now I'm just solving for x. I'll add 30 to both sides. That will leave me 2x's on the left. It'll leave me x plus 58 on the right. I will subtract x from both sides, and I'm left with x equals 58 degrees, and that one's been solved. Question 1E, this one's a bit of a mess. There's lots of angles here and there's missing bits of information. I might do this one as a two-stepper because I can see here that I've got 90 degrees making up those two angles, so I've got complementary angles. And again, there's another right angle here, so I've got another set of complementary angles here. So what I'll do is I might add my own pronumeral. I'll put a y in here and I'll solve for that first, and that will give me 2 steps to get x. Again, there's probably a couple of ways of doing this. This is the first one that's jumped out at me. So I know that y plus 26 is going to give me 90. Because of complementary angles, they add to give me 90 degrees. I'll take 26 from both sides, and I'll find that y is equal to 64 degrees. And now that I've found that, I can go hunting for x, because I know that x plus y are also complementary angles that will give me 90. So I've got x plus 64. I'll just take 64 from both sides. And I know that x will be 26 degrees. And that one's solved as well. Question 1F. I've now got angles that meet at a point, and I've got 3 pronumerals or letters to try and find the answer to. So we might attack this in the easiest way that I can see. So there'll be a couple of ways again of doing this, but I can see that vertically opposite angles are equal. So x is nice and easy. X is 48 degrees. And then we'll have a look at solving for z. So I can see that z and 48 would make up 180 degrees because they're supplementary angles. So we'll say z plus 48, we don't really need the degrees there, are going to give me 180 degrees. So if I subtract 48 from both sides, z will be 132 degrees. So we've got that one solved. And finally, we're after y. Now, y plus 35 is vertically opposite z. So now that we know what z is, we can solve that. But just so it's nice and clear, in the third one, z is equal to y plus plus 35 because they are vertically opposite. And we'll sub in what we know at 132 being equal to y plus 35. Let's take 35 degrees from both sides and we'll be left with 97 being equal to y. So just so we're nice and clear, y is equal to 97 degrees. And it's a bit of a mess here, so I'm just going to highlight my answers. You might choose to underline them just so that it's clear for your marker. Question G. This is where we need to introduce one of those formulas that we started with at the beginning, so you might choose to duck back and have a quick look at that. And that formula reads that the individual angle, or one angle, like the question's asking us over here, in this regular polygon is used with the following formula. You have a quick count, and I can see that this has got 10 angles, also has 10 sides. It is regular, so every angle and side is the same, so this formula is fine to use. And so the individual angle is going to be 180. N stands for the number of angles, so we've got 10 minus 2 all over 10. So that's going to be 180 multiplied by 8 all over 10. Don't forget BODMAS, you've got to do brackets before multiplication. So each individual angle will be 143 degrees. Question 1H, we're back to a external angle of a triangle is equal to the sum of the two opposite internal angles. So this one's nice and easy. So we know that V will be equal to 56 plus 87. So V will be 143 degrees. And 1I, we have got a regular polygon again. So we know that all the angles are going to be equal. And we also want to know of each angle. So we need to know individual angles. So we're going to use the same formula as above, which is here. But this time, we might just make ourselves a note here that remember each angle is equivalent to A plus 20. So there'll be one extra little step into this one. So in other words, if we start to fill this out, each individual angle will be A plus 20. And then we've got 180. Number of angles is 5. So we'll fill in the formula. And that means that we'll have A plus 20 will be equal to 180 times 3, which is 540, all divided by 5. If we keep simplifying, A plus 20 will be equal to 108. Oops, that's not 108. And then finally, if we subtract 20 from both sides using the balance method, A will be 88 degrees, and we've solved that question. Question 2, very similar to the question above, not very much room to solve it, so I might just move this one over here. So we'll work over here for this one. We'd like to use the same formula again, so we'll just borrow that. And this time, we're just going to check our question. The polygon is regular, so we're laughing, and each angle is 3A plus 10, similar to the one in before this one, but just with a little bit extra in it. So each individual angle is going to be 3A plus 10, and then as we fill this out, the number of sides is 11, so it's going to be 11 minus 2 all over 11, and so we'll find that 3A plus 10 is equal to, and using a calculator, we get 147.27. And now we're just turning to the balance method. So we'll just subtract 10 from both sides. We'll end up with 3a on the left, and we'll end up with 137.27 on the right. Now we'll divide both sides by 3, and we'll find that each individual angle is equal to 45.75 degrees. Question 3, last one. We're after the sum of the internal angles of a regular 50-sided polygon. Okay, now this time we don't want an individual angle, we want the sum. The sum of the angles, okay? So we're going to use that slight different iteration of the formula. So this time, if we're just after the sum of the angles, we're going to just use 180 n minus 2. That will become our formula. It's no need to divide because I don't want to know what each of the individual angles is. And let's sub in and solve. We've got 180. We've got a 50-sided shape, which means there's 50 angles, which means that if we take 180 and multiply it by 48, we'll find that the total internal sum is 8,640 degrees.